Hello students, I'm back with another video, and in the last lecture we have seen applications of dimensional analysis. Second application we have seen where we have learned how to derive relation between several physical quantities or different physical quantities. We have seen one example on that, and then we have seen what are the limitations of deriving a formula or a relation with the help of dimensional analysis. Fine, so we'll see two more problems. One example problem we'll see, and then we'll do one previous JEE question. So the second example that we'll see is something like, let me write it down. Okay, so in this example we need to derive a formula for centripetal force with the help of dimensional analysis. So when an object of mass m moves in a circular path with certain speed v, then it experiences a force towards the center. It experiences a force towards the center of the circle. Okay, and it is given that this force depends on mass of the object, speed of the object, and radius. So based on this information we need to derive a formula for this force. Okay. So the first step that we do is, we know that force will be depending on mass, speed and radius, but we do not know that how exactly it will be depending, meaning what will be the powers of mass, speed and radius to which the force will be related. So the main goal here is to figure out the powers itself. So the first step we are going to write is that force is proportional to mass to the power some x, speed to the power some y, and radius to the power z. There can be a proportionality constant here, which will be a numerical value. That proportionality constant I am representing with k. So the force formula becomes k into m to the power x into v to the power y into r to the power z. Now the next step is to equate the dimensions on both sides, okay, which is based on principle of homogeneity. Principle of homogeneity states that each and every term in any mathematical formula must have same dimension. So we are going to use that property here. So the dimension of force should be same as dimension of k into m to the power x, v to the power y and r to the power z. Okay. Now we know the dimensional formula for force. It is better to write the RHS and LHS first. So k into m to the power x, v to the power y and r to the power z, dimension of this thing should be same as that of force. Fine. Now let us put the dimensions of each and every term. Here k is a mathematical constant, and we know that mathematical constants are dimensionless. So k will not be having any dimension here. So we can ignore k. For mass, the dimensional formula is capital M. So capital M to the power x. V here is speed. For that, dimensional formula is LT minus 1. So whole to the power y. R here is radius, whose dimension will be L. So L to the power z. Now the dimension of force, we are aware it is ml t minus 2. Fine. Now the aim here is to bring the same bases together with their appropriate powers. So power here on in LHS we have only one term for mass, and power of that is x. For L we'll get y plus z, as from the second term the power is y, and for the third term the power is z. And t to the power minus y, and that should be equal to m. So here power of m is 1, power of L also is 1, and for t it is minus 2. So now what we are going to do is we can equate the powers of same basis. Okay, I hope you all are able to follow. Here power of m is x in LHS, whereas the power of m on RHS is 1. So x should be equal to 1. So from this we get the value of x. Similarly, power of L on left hand side is y plus z, and that should be equal to power of L on right hand side, which is 1. This is another equation we get. And if we equate the powers of time, that is minus y, and that should be equal to minus 2. So from here we get y equal to 2. So we have got x value and y value. Now we can get z value by putting y in this particular equation that we have. So that will give us 2 plus z equal to 1, and from there we get z as minus 1. So now we have the values of x, y and z. So now if you put this in our force formula, if you put the x, y and z values, then it becomes k into m to the power x, which is 1, v to the power y, which is 2, and r to the power z, and z is minus 1. So with the help of dimensional analysis, the formula that we get is k into mv square by r. Okay. Now we know that there are certain limitations when we derive a relation with the help of dimensional analysis. Like in this particular case, we cannot find the value of k. Okay. K is a mathematical constant, and what will be value of k, that cannot be determined with the help of dimensional analysis. So the actual formula for centripetal force is mv square by r. So k comes out as equal to 1, but that cannot be derived with the help of dimensional analysis. Okay. So I hope this is clear. I'll just zoom out a bit to get a glance at the complete solution. Fine. If you need, you can take a screenshot. Now we'll go for the next question. Okay, let me load the question. Okay, so we have the question now on the screen. This is the previous JEE Mains problem. It was asked in JEE Mains 2020. Let us go through the question once before going for the solution. Here they have given if momentum, area and time are taken to be the fundamental quantities, then the dimensional formula for energy is. So in this particular question they are taking momentum, area and time as the fundamental or the base quantities, and we need to write energy in terms of momentum, area and time. So this is clearly the application of second application of dimensional analysis itself, as we need to derive a relation between energy, momentum, area and time. Fine. So we are gonna solve it in a similar manner. The first step is energy will be related to x power of momentum, y power of area and z power of time. Okay. Now here again there will be some proportionality constant k into p to the power x into a to the power y into t to the power z. Now let us equate the dimensions on both sides. E is energy. The dimensional formula for energy is m L square T minus 2. Okay. K is dimensionless. P is pressure. Sorry, P here is momentum. So for momentum, the dimensional formula is ml T minus 1. So whole to the power x. A is area, so that comes out as L square to the power y, and T is time, so that remains as T to the power z. Okay, now I'm going to simplify the right hand side first, and I'm going to put it in on the left hand side. So if I bring the bases of same type together, we have only one term for mass, so that becomes m to the power x, and for L overall it will come out as x to L to the power x plus 2y. Okay, and we'll get t to the power as minus x plus z, and that should be equal to m to the power 1 L square t to the power minus 2. Okay. Now again the same process, we are going to equate the powers of the same basis here. Power of x on left hand side is, sorry, power of x on right hand side is 1, so x should be equal to 1. So from there we are directly getting the value of x, and then if we equate the powers of L, then x plus 2y should be equal to 2. So if we put x equal to 1 here, we are going to get 1 plus 2y equal to 2. Excuse me. And if we simplify this, 2y will be equal to 1, and that gives us y as 1 by 2. Okay. So we have got x, we have got y, only thing remaining is z. So if you equate the power of t on both sides, power of t on left hand side is minus x plus z, and that should be equal to minus 2. X value is 1, So minus 1 plus z should be equal to minus 2. So that will give us z as minus 1. So from here, if we go for the final expression, ignoring the constant, if I just write E, dimension of E, taking momentum, area and time as fundamental quantity, then that will become p to the power 1. So we can leave it as just p into a to the power 1 by 2 and t to the power minus 1. Okay. So from here we can see that the answer comes out as the second option. Okay. Sorry, not the second option, the third option. So answer will be the third option, that is p a to the power 1 by 2 t to the power minus 1. Okay, you can have a look at it. Fine. So now we can move on to the next application, the third application of dimensional analysis. Third application of dimensional analysis is conversion of units. Okay. With the help of dimensional analysis, we can convert any physical quantity from one unit to the another. Okay. So here the concept is that the product of numerical value and unit, it remains throughout different systems. Okay. The product of numerical value and unit remains constant throughout the system, meaning even if you are going from one unit to the other, the product of the value, the magnitude of the physical quantity and the unit remains same. Okay. So in short, this information can be written as n into u is constant. Okay. And while solving problems, the expression that we use is n1 u1 equal to n2 u2, which is basically equating the numerical values and the units in two different systems. Okay. So let us see an example for this. We'll take a very basic example like converting 1 joule into CGS unit. Okay. So but the question is convert 1 joule to CGS unit. So here the first step that we need to do is, first we need to write the dimensional formula for the physical quantity which is being converted. Okay, like for in this particular example, we are converting joule to CGS unit. So we know that joule is SI unit for work or energy. So we can take dimensional formula for either work or energy. The dimensional formula for work, as we know, is m L square T minus 2. Okay. It is m L square T minus 2. Fine, we'll be taking a very short break. Okay, fine. So the first step is to write the dimensional formula for the physical quantity that we are converting. So here we are converting joule, which is the SI unit of work, and dimensional formula for work is ml square T minus 2. Okay. Now the next step we write n1 u1 equal to n2 u2. Okay. So here n1 is the value in the first unit. So in this case we are converting 1 joule, so n1 becomes 1, and in place of u1 what we need to do is we need to write the SI units of the base dimensions on which it depends. For example, the SI unit of mass we need to write first, that is kg. Then we need to write a SI unit of length, that is meter, and for time, that is second. And on the right hand side, n2. So n2 we need to figure out. We need to figure out what is the value of 1 joule in CGS unit. So n2 for now we'll leave as it is. n2 into, now in CGS unit, the CGS unit of mass is gram, for length it is centimeter, and for time it is second minus 2. Okay. Now from here the next step we need to do is n2 can be written as kg by gram into meter by centimeter whole square into second by second whole to the power minus 2. Now we are going to convert. Fine. So we need to cancel the units out. So either we can convert the SI terms into CGS terms or the CGS units into SI unit. So we can write kg. Kg here means 1 kg. 1 kg is 1000 gram. So 1000 gram by gram into 1 meter is 100 centimeter. So that can be written as 100 centimeter by centimeter whole square. Second, it's gonna get cancelled. It will be just 1. We can cancel gram, we can cancel centimeter. So from here we get 10 to the power 3, and from here we'll get 10 to the power 4. So overall it will come out as 10 to the power 7. Okay. So we have got the required value. So n2 comes out as 10 to the power 7, right? Yes. So 1 joule, 1 joule is 10 to the power 7 erg. Okay, if I write it in complete words, 1 joule is equal to 10 to the power 7 erg. Erg is basically the CGS unit of energy. Okay. Fine, let me zoom this out. Okay, so I hope this example is clear. We'll see one more problem before moving to the next part. Okay, let us have a look at this question. The question is, the density of a piece of clay is 1.8 in CGS system of units. The corresponding value in SI unit system is. So we need to convert density from CGS unit to SI units. Okay. So we are going to follow the same steps. The first step is to write the dimension of the physical quantity which is being converted, the dimensional formula. Here we are converting density, and the dimensional formula for density is mass by volume, so that makes it m into L to the power minus 3. Okay. Now the next step is N1 U1 should be equal to N2 U2. Okay. N1 is the value in the first unit and N2 is the value in the second unit. Here the first unit that we have is CGS unit. So value given is 1.8. So 1.8 into U1. In CGS unit, again the procedure is that we need to write the CGS unit of the base dimensions that we have here. For mass, the CGS unit is gram, and for length it is centimeter to the power minus 3, and that should be equal to N2. So N2 we need to find, which is the value in SI unit, and for U2 the SI unit of mass is kg, and for length it is meter to the power minus 3. Okay, now from here if we simplify, N2 will become 1.8 into gram by kg into centimeter by meter whole to the power minus 3. Okay. Now in the next step we need to cancel out the units. So for that I am going to convert the SI values into CGS values. So 1 kg is 1000 gram into 1 meter is 100 centimeter. So centimeter by 100 centimeter to the power minus 3. So if you simplify this, here gram will get cancelled, and from here we are going to get 10 to the power 3. Sorry, 10 to the power minus 3. Here centimeter gets cancelled. 1 by 100 becomes 10 to the power minus 2, and 10 to the power minus 2 into whole to the power minus 3 becomes 10 to the power 6. So this will come out as 1.8 into 10 to the power 3. So here the N2 value will be 1800. Okay, so that means 1.8 gram per centimeter cube is 1800 kg meter cube per meter cube, or meter to the power minus 3. Okay, so this is the conversion relation here. So we can clearly see that the correct answer will be the second option. Okay, so you can go through this question once. You can pause the video if you want. We'll go for the next question now. Okay. Okay, let us solve one last problem based on this application. So this is a previous JEE Mains problem that we are going to solve. Okay, let us go through the question once. The question says the density of a material in SI unit is 128 kg per meter cube. In certain unit in which the unit of length is 25 centimeter and unit of mass is 50 gram, the numerical value of density of the material is. Okay. So here in this question they are not converting between any two standard units. One of the unit here is SI unit, whereas the other one they have taken a hypothetical unit in which the unit of length they have taken 25 centimeter and unit of mass they have taken as 50 gram. So we need to find the value of density in this new hypothetical unit that they have created. Okay, anyways the steps will be same, there will not be any difference in that. So the first step, as we know, is that we need to write the dimensional formula for the physical quantity that we are converting. So here we are converting density. Okay, the previous problem was also similar only. Okay, so the dimensional formula for density is m l to the power minus 3. Okay, now the next step is n1 u1 will be equal to n2 u2. Fine. So n1 here is 128 and the first unit that they have given is SI unit. Okay, so 128 into, for mass the SI unit is kg and for length it is meter. So kg meter to the power minus 3. Now n2 we need to calculate. Okay, and for u2 if we see, the unit of mass they have taken as 50 gram. Okay, your unit of mass is 50 gram. So in place of mass we'll write 50 gram, and for length they have taken 25 centimeter. So 25 centimeter whole to the power minus 3 we need to take. Okay, now we just need to simplify this expression. So that will give us n2 as 128 into kg by 50 gram into meter by 25 centimeter whole to the power minus 3. Okay, now let us simplify this. So kg can be written in terms of gram. 1 kg will be 1000 gram divided by 50 gram here we have, and 1 meter will be 100 centimeter divided by 25 centimeter whole to the power minus 3. Okay. So here gram gets cancelled, 1 0 can be cancelled, 5 this will become 20. Here centimeter gets cancelled, 25 4 times will be 100. So this becomes 128 into 20 into, here 4 to the power minus 3 we will get, which can be written as 1 by 4 into 4 into 4, okay, for simplification purpose. So this will go 5 times, then here 4 3 times 12, 2 times 8, then again 4 8 times 32, So 8 into 5 becomes 40. Okay. So N2 value will be 40. So the value in the new hypothetical unit that they have created will be 40. So let us see which option we have. So we can clearly see here that the correct answer will be the first option. Okay. So this is all we had in the applications of dimensional analysis. In the next chapter, in the next class, we will be starting with the error analysis part. So although this chapter looks easy, and it is easy in fact, but it is very important, as every year at least one question they ask in JEE Mains as well as in JEE Advanced. Okay. So we will continue this chapter in the next class. For now, I have to say goodbye, and if you like, please subscribe. Thank you.